We want to look at a special type of mean, and this is called a weighted mean. And I'm going to, again, go with the notation. And it's what happens if the data has varying weights. What that means is some value is worth more than another value. And so this is going to be our notation for it. I add up all the individual values times their weight divided by the total weight. And a common place where you see this is in a grade point system. So let's say we have the basis of a 4-point grading system. We want to figure out a GPA. And so these are the weights per your credit hour. And so if you get an A, that has a weight of 4. And if you get a B, that has a weight of 3. And so a B plus is 3.5, an A minus is 3.75. Depending on the weighting system, there's a different value for those. But we'll just focus on these. A equals 4, B equals 3, C equals 2, D equals 1, and an F is 0. You don't get any value for that. And so you can calculate a GPA based off of the grades. And again, this works for any weighted system. I'm going to use GPAs here where the thing you're averaging has a weight. And so let's say you took these classes where you had a grade, a final grade, a C, a D, an A, a C, and a B. And this was 3 credit hours. This was 4 credit hours. This was 1 credit hour. D is 1, the A is 3, the C is 2, and the B is 3. And so this is my X. This is my weight. The weighting is going to be how many hours I put into it. And then my X value is going to be what these grades are worth. And so I'm weighting it by how much time I spent getting this many points. And so C has 2. And D has 1. And A has 4. And B has 3. So here are my points. But I don't get the average of this. I get the average of the weights. Because think about it, a 4-credit course should be better for your GPA than a 3-credit course. This should be better for you. So we need to take this formula and create our weighted averages. So the thing we need is the X value for each row times W. And one of the things you'll note about sigmas is we'll make columns out of sigmas. So I have all my W's here. I can add up my W's down at the bottom. So the sum of my W's equals the addition of this column. So that's 7, 8, 11, 13, 16. And so there's 16 credit hours. But I need to get my X times W. And so what I do is I make another column where I take 2 times 3, that's 6. 2 times 4, that's 8. 1 times 1, that's 1. 4 times 3 is 12. 2 times 2 is 4. And 3 times 3 is 9. And I sum up this column. So notice my sigmas add to additions down columns. And so I get 14, 15, 27, 31, or 40. And so my weighted average is the sum of my xi's times w divided by the sum of my w's, which in this case is 40 divided by 16, or approximately 2.5. And so the GPA is 2.5. And this is how weighted averages work. And so this A here, notice how it gives a weight of 12. While this C gives a weight of 8 compared to this C because of the difference of the credit hours coming through. And so weighted averages are actually really, really important. Finding weighted means have a way of taking care of the importance of particular data values. And we'll come back to this concept. This concept can actually be reversed a little bit. If I have a frequency distribution already, remember when I did my frequency distributions, I had the midpoints of my histograms. And that was 2. And so I have the midpoint values here. And I lost the data inside them. So if I see someone's midpoints, I can at least get an idea of what their mean was without having the original data. So we go back to the frequency distribution we did in the previous lecture. And let me just scroll down and recreate it here. Let's say if I see this graph, my midpoint was 172.5, and then I had 208.5. Remember I had 7 classes. 244.5, 280.5. So I'm recreating the out-of-pocket prescription. And 388.5. Those were all my midpoints. And I had, 3 of these. That was 3. 2 of these. Then I had 5 of these, 6 of these, 7 of these. Remember I said 50% of the stuff was in this bulk here? And then 4 of these, and 3 of these. And so there's my distribution. So if we got this, and we wanted to know what was the mean of this data, well, we can use the idea of kind of weighted averages. We can kind of say, well, this group of stuff is kind of around these points. And so we can make this kind of the data collection we have. And I can say the average of this is going to be the sum of my midpoint value, so I'm going to call that x mid, times its frequency, divided by the number of things. And so if you recollect, we had 30 things, but you could always refigure this out. There were 3 and 2 is 5, right? And then we have 3, 2, 5 more 10, 6 is 16, 17, or 23, 27, and 30. So n was 30. And so if I'm given data and I lost the information, I can get an idea of the mean. And so what I need to do is I need to sum up this midpoint times its frequency and then divide it by the number of pieces of data. Now this relies on the idea that however many things I have in here, the average will be close to the midpoint. It's not always the case, but it's not a bad approximation. Now if I replace this back into column data at 172.5 times 208.5. So notice I'm taking these midpoints from this graph and I'm turning them into pieces of data. 316.5, 352.5, and 388.5. And for frequency, I had 3 of these, 2 of these, 5 of these, 6, 743. So that was my frequency. Now, I know if I add up, remember n was equal to the sum of the frequencies, which in this case is 30. And so I need to make a column of my x values. So this is my x and this is my f. Sorry, my table's getting close to my formula. And so now I need to do x times f, or the midpoint times the frequency. So 3 times 172.5, calculator fun. And I'm multiplying this number by this number to create a new column. And this number by this number. Apologize as I punch away on the calculator here. 1165.5. And so I want to add up my xf's, or my midpoints times the frequency, and I get 8,631. And so my average is the sum of all those x's times their frequency divided by n, or 8,631 divided by 30, or approximately 285.50. Or I'm sorry, that's what the real value is. Let me actually type this on the calculator here. My bad. Because I have the actual data in the background, I can peek at the real value. And the estimation is 287.7. So if I go back and I go grab that data, and this is something you'll be able to do in Excel after the next videos, and calculate the mean, I get 285.50. If I use the midpoints, I can approximate it at 287.7. So that's not a bad approximation. Now, no, most of the time, you are only going to see the data in this form. You won't have every piece of data. Sometimes there's just too much of it to do. And so this isn't a bad way of approximating when you're reading someone else's data. And so this is similar to a weighted mean, where the midpoint times the frequency. You notice the other thing we introduce here is these sums. With sigma notation, is we add down columns. And so whatever we're summing, we make a column of that data. Play with it. Your homework will get you there.